Before you can take Rupert to the bar and ask whatever you want there and get him drunk and do whatever you want with him, we have some time for a few questions. So just raise your arm and I'll get the microphone to you.
Hello. Hey, have you discovered any effective way of establishing telepathic connection between human beings?
Between human beings? Well, yes. I think that the evidence for telephone telepathy is evidence for telepathic connection. Is this working? Yes. Yes, I think that the evidence I've just talked about is evidence for telepathy between humans. The telephone telepathy, email telepathy, and the SMS telepathy. You mean to increase it? To make it happen more? Okay. I don't know any techniques for making it happen more except practicing. And there are people who have intuition training workshops. And I'm trying to persuade people who give those workshops to get the people to do my telephone telepathy test before and after the workshop, which should provide objective evidence that their methods work. I myself don't try training people to be more intuitive, but some people do that.
Is there any other question?
Hi, Rupert. Would you agree to the notion that it's not only within biology, but within all sciences, that the common denominator as a critique against scientific rigidification of thinking, or the ossification within the sciences, the critique that could be leveled in a very broad and controversial way is that everything we know is simply wrong? I knew that was the easy one, maybe a little bit rhetorical, but nonetheless.
I don't think everything we know is simply wrong. I mean, jet planes wouldn't work and modern drugs wouldn't work and so on if it was all wrong. I think science isn't wrong, it's limited. And it's constricted by dogmas. So most of what scientists positively know is fine, I think. What's wrong is when they say that certain things don't exist or shouldn't be investigated. That's the problem. And the problem with science is dogmatism. And in fact, this is the basis of a new book I've written. It's coming out in January in Britain. It's called The Science Delusion. And the science delusion is the belief that scientists already know the basis of reality, in principle, leaving only the details to be filled in. I think that's a delusion. I think we know very little. We know least of all about our own minds. Consciousness is one of the biggest problems for modern science. It simply doesn't fit into a materialist worldview. So in my new book, I take the 10 dogmas of materialist science, and I turn those dogmas into questions. For example, the dogma "the mind is in the brain" becomes the question, is the mind confined to the brain? And I've talked about that this evening. Another dogma is the laws of nature are fixed. That becomes, are the laws of nature fixed? Another dogma is matter is unconscious. Is matter unconscious? Another is nature is purposeless. Is nature purposeless? When you do that and turn the dogmas into questions, in every case, science opens up. New questions become possible, new lines of research become possible, new evidence fits into place. And so I think science can be transformed, expanded, and radically improved. And I think we need more, not less. And anyway, that's the theme of my forthcoming book, The Science Delusion.
Any other? Oh. Hi. When you talked about the herd of starlings, or the starlings moving, you said it was like a collective intelligence, that they were one, in a sense. So, if that's the case,
what kind of intelligence, can you say, is moving the one? And if you make a parallel to human beings, looking at maybe cultures, or maybe the whole global culture as such, do you find a parallel? I mean, I've also heard people talking about a critical mass, 10%, maybe 20%, and then the rest will follow. I mean, I was just wondering about these concepts. So what is moving the herd, you can say?
Well, not much is known about starling flocks and other flocks of birds. There have been a few recent studies in Rome, in Italy, that have used high-tech methods of filming them, slowing it down, and looking at the behavior of the flock. And it's clear that they're not following leaders. It's clear there's a kind of a movement sweeps through the flock, and it can start at the back or the front or the side. There's no particular place where it starts. But the whole group responds. Now, how that works, nobody knows. There's been very, very little research on these phenomena. In some birds, when they fly, they have leaders, like geese. They fly in a V formation, but starlings are quite different, and so are many other species. Now, exactly how it works, whether it's a small consensus that spreads, whether the whole group field or group intelligence can make decisions that influence the individual birds, nobody knows. The analogy with the magnetic field is interesting. The field of a magnet emerges from the magnetic domains, lots of little magnets within it. When they're all lined up, the individual magnets produce the overall field of the magnet, and that in turn works back on the individual tiny magnets within it. And I think something like that's happening with the starlings, but we just don't know how it works. This is the kind of research that could be done, but very little has been done so far.
Can I ask another thing in relation to that?
Yes.
It's just that I thought of this parallel to shamanism, actually, where, as I understand it, in, for example, Indian culture, the shaman had the ability to somehow connect to a meta buffalo, like a buffalo supersedes
Yes.
the herd. And actually, you can say a meta buffalo that was in a higher principle than the herd.
Okay, the question is about shamanism and how a shaman might connect to the herd of animals like buffalo. I think probably shamans do have ways of connecting with groups of animals, individuals or groups. But how they do it, we don't really know. One of the problems is that our anthropologists who've studied tribal societies have on the whole gone there with a kind of Western materialist mindset and assumed that all these things are just make-believe, they're not real. Instead of studying things that are most interesting, they've ignored them. And so we know a lot less than we should know about the relations between shamans and animals. I think in the modern world, some people who have those abilities in modern societies practice as animal communicators. Some animal communicators seem to have an extraordinary way of linking to animals. And shamans in traditional societies are the interface between humans and the non-human world, animal and plant world. I think we have a great deal to learn from them, and I just can't answer your question of how they know.
Any other question?
Hello. It would seem that the possibilities of establishing experiments that would research the connection of this resonance in relation to quantum physics, as you mentioned, would be fruitful. Is that in any way a priority or under works?
I'd love these things to be researched in the realm of quantum physics. I mean, some of the best experiments are actually in the realm of chemistry, and they're quite cheap and quite simple. The problem is persuading chemists or quantum physicists to do them. I can't do them myself because I'm not a chemist or a quantum physicist. And you know, I have to say, I gave a talk yesterday at the Niels Bohr Institute here in Copenhagen to a group of physicists. And I think it's fair to say that they were, on the whole, quite open-minded. But they're not going to drop what they're doing and take up this research because there are no grants for it. They're all doing something else anyway. That's the problem. And for any scientist to do unconventional research, there are tremendous disincentives. You can't get grants, you might damage your career, you'll be ridiculed by your colleagues. It's really hard to persuade people to do this, even though the experiments are so simple and in some cases very cheap. I mean, for example, in physics, the experiment I'd really like to see for morphic resonance. Morphic resonance says that if new things happen, when they happen again, they should happen more easily, like rats learning a new trick. But this should apply to low-temperature physics. That most things physicists study, like hydrogen atoms, have been around for billions of years, and the habits are very deeply entrenched in grooves. You won't see any change after billions of years. But the background temperature of the universe is 2.7 degrees K, 2.7 degrees above absolute zero. So anything below that temperature may never have happened in nature. In low-temperature physics labs, they're studying processes at 0.1 degree K, which would never have happened in nature. When you do that, weird things happen. Bose-Einstein condensates, superfluidity, superconductivity, all sorts of weird properties arise in materials. And so I think the best way to test for morphic resonance in quantum physics would be to do, in this low-temperature physics experiments, to do the same experiment over and over again, and I would predict that it would happen more quickly or more easily as time goes on. Unfortunately, at present, scientists assume that everything's the same, and they average their results, or they just take one result, usually the best one, and publish that, and they don't look for changes in time because they don't expect to see them. But I think low-temperature physics could provide a really good way of testing this theory. But I've never yet succeeded in persuading a low-temperature physicist to do it. That's why I concentrate on the whole on very simple experiments, that it's very hard to get scientific funding for unconventional research. So my solution to that is to think of experiments that are so cheap that you hardly need any funding. Most of the things I've talked about this evening can be done for a few $100s. We're not talking tens of billions like the Large Hadron Collider. We're talking about radical frontier research that can be done by children or by teenagers on mobile phones at very little cost indeed.
Okay, the last question.
First of all, I would like to thank you for inspiring and quite interesting talk. But I would like to turn focus on something you actually showed tonight in some of your slides. Can you turn those back on? The last slide, the Flynn effect or something like that you called it. It was a graph. That one. Yes. So I don't know if it struck you the same way it struck me, but to me this seems quite linear, right?
Quite linear, yeah.
Quite linear. I don't know if you did the correlation factor in this, but to me it looks quite linear. Isn't that quite surprising that an effect like this, if we say that your theory is correct, that a process like this would be linear?
I find it surprising it's linear. I would expect it to reach a kind of asymptote. I would expect it to level off. I mean, whether it will in the future, I don't know. And, you know, I just don't know why it's so linear. I agree, but I would expect that if it goes on, it would level off like this.
But it brings up another very interesting question about theory, and that is, can telepathic communication only go on in between two people, or can one person spread out to several people? Because if the last thing is the case, then you would expect exponential raise in the IQ test over years.
The question is about telepathy. Would it just go to one person, or can it spread out to many people? That's a really interesting question, and I don't think anyone's ever looked into that. I haven't looked into it myself. I mean, the total number of people in the whole world doing research on telepathy is about 5. You know, this is such a taboo subject. There's hardly any. You could do hundreds of PhDs on this if it were allowed in universities. and ask that kind of question. But I just don't know. Nearly all the research that's been done has been done one-on-one. So, I mean, these questions are really good questions, and they're ones that could probably be answered, but they can't be answered now. And the frustrating thing in all this research is that so many questions could be answered relatively cheaply, you know, if there were more people working on it. But even after I did my work on dogs that know when their owners are coming home, published it in scientific journals, talked about it in universities, how many people have followed this up and done more research on it? The answer is zero. There's simply no incentive in the scientific world to do anything unconventional. So I think things will change, and then I think your question, for example, about telepathy would be extremely interesting, and also tests on morphic resonance effects to see if they approach asymptotically a limit. They could be done as well, and I would expect that they would show they may show linear effects to start with, but I would expect them to then stop being linear.
Okay, that was the last question. So from now on, you can just ask Rupert anything around. Before we take a short break and A Key is going to play, I want to say that this was the last Science and Cocktail session of this year, and that we will restart in January. So if you want to hear about it or be in contact with, you can just ask for a pen and a paper at the bar and write your email, and you'll get the emails when it restarts again. So let's applause Rupert again.